Hello everyone, Mr. Minnick is my name, math is my game, and today's lesson, it's out of chapter 4, it's the second section. The title officially is Standard Form of a Quadratic Function. Standard Form of a Quadratic Function. I'm going to go ahead and use my magic marker here, bring some attention to it. I had been using y equals, they're using f of x equals, and that's okay. Maybe my magic marker didn't quite get what I was trying to do there. There it is. Is that big enough for everybody to see, I hope? F of x equals, if you want to use a y in place of f of x, that's cool. But f of x equals, or y equals, ax squared plus bx plus c. That's called standard form of a quadratic function, or standard form of a parabola. Notice that they're telling you that a is not allowed to equal 0. That's true. A is not allowed to equal 0, because if a equals 0, I don't know if you remember what happened from last week. It ends up just being a line. It ends up being a line. But we're not graphing lines. We're graphing quadratic functions, and when you graph quadratic functions, of course, their graphs look like a U-shaped thingy that we call parabolas. How we doing so far, okay? So one thing I'd like to do is I'd like to compare vertex form to standard form, and we kind of did this last week. Vertex form versus standard form. In vertex form, we have y equals a times x minus h, the quantity squared, plus k. In standard form, we have y equals ax squared plus bx plus c. And I'd like to point out that the a's here are the same. That the a in vertex form and the a in standard form, they have the exact same effect on the whole thing. What's that mean? It means if a is positive, the graph opens up. What's that mean? It means if a is negative, the graph opens down. It means if a is bigger than 1, then the graph is a vertical compression. Okay. One thing I probably ought to point out, this c value from standard form is called your y-intercept. It's your y-intercept. We'll make that official. The graph's going to go through the point 0, comma c. The graph's going to go through the point 0, comma c. From vertex form, we know that our vertex has coordinates h, comma k, and we know that our axis of symmetry is x equals h. But standard form, aside from the a value and aside from the y-intercept, standard form really doesn't tell us much. That's the bad thing about it. It really doesn't tell us much other than the y-intercept. So far, all right? Cool beans. So if you had to pick between getting a function given to you in standard form versus vertex form for the sake of having to graph it without a calculator, I would pick vertex form all day, every day. So problem 1. Well, let's see. I might be jumping ahead of myself here. They didn't give us any formulas. What are they saying? Problem 1, find the features of. Okay, this is kind of cool. I like this. We'll roll with this. Problem number 1. They want us to find the features using a graphing calculator. That's probably not a bad idea. That's something that I often overlook. They want us to find the vertex, they want us to find the axis of symmetry, and they want us to find the maximum or the minimum value and the range of the function. So if you don't have a graphing calculator, there should be some nearby your desk if you want to grab one, or if you need to walk across the room and grab one. This is something that, I'll be honest with you, I'm guilty of. A lot of times I don't go over how to do these kind of things. I'm going to write that on the sideboard so I can see it. So the function in question is y equals 2x squared. 2x squared plus 8x minus 2. So if we're going to use a graphing calculator to do this, we need to start a new document, and we want to go to a calculator page. Everybody know how to go to a calculator page, I hope? From our calculator page, we've got our graph entry edit line. We'll go ahead and type in 2x. The squared button is next to 4, 2x squared plus 8x minus 2. And we'll go ahead and press enter. Now, right off the bat, I notice my vertex is lower than my graph shows. My vertex is lower than my graph shows. You guys have the same problem on yours too? Okay, so my vertex is lower than my graph shows. Does anybody have any idea how we could accommodate for that? How we could make the calculator show us the vertex? If I were walking in the room, I might walk toward the end opposite from the doors. If I do that, where am I going? I'm walking toward the Microsoft computers use this operating system. Where am I walking to? What am I opening? The windows. We're going to go to the window. How do we get to the window? Menu. We're going to press menu, menu, menu. Window. Now, there's some pre-made windows. Some people like zooming in, some people like zooming out. If I'm being perfectly honest with you, I like option A. Do you see the one that says Zoom Fit? I like that one. I'm going to go ahead and click on that, Zoom Fit. And it should show me my vertex. Hey, there it is. But it doesn't give me the coordinates. It doesn't give me the coordinates. So maybe I'm going to need to calculate that. Or maybe I could turn on my grid. I'm going to press menu. I'm going to press view. I'm going to go grid and lined grid. When I do that, maybe now I could see, maybe I can't. Yeah, that probably didn't help much. Dang it. Maybe this TI Inspire isn't the best calculator to do this with. Maybe there's a better one, a beautiful one, a free one that's online. Desmos? But while I got this calculator, I might as well go ahead and see what I can do. I'm going to press menu. I'm going to press analyze, and I'm going to, you know what? I'm not going to press analyze. I take that back. This is so cool. You might want to make a mental note of this. Menu. Come on, Bueller. Menu. Trace. Graph trace. Menu trace, graph trace. That's so cool. What menu trace, graph trace will do is if you can use the directional pad and move your cursor, the calculator should kind of stop when you get to the minimum. And it says, hey, there's your minimum. Can you make out what it is? -2, -10. So that is also our vertex, right? Because the vertex occurs with the min and the max. So -2, -10. So the vertex is -2, -10. Does this function have, well, I guess I just said minimum, so it has a minimum. What's our minimum value? What's our minimum value? Anybody? The minimum value is it's -10. It's the y value of the vertex. Good. And then the range, since the graph opens up, the range of this thing is going to go from -10 up to infinity, like that. All right. And the axis of symmetry of this thing, the axis of symmetry would be x equals what? X equals -2. Okay. So we can use the graphing calculator to find this, and the takeaway from this should be trace, graph, trace. Okay, trace, graph, trace. That's going to be the most effective way to find that if you use trace and then graph, trace. Okay. Trace and graph, trace. How are we doing so far? All right. Was everybody able to find that on the calculator? The trace graph? Good. Cool. Cool. So the next item up for bids then is for us to use these formulas. We talked about this one on Friday, Thursday. We weren't here Friday. Use my magic marker again. Rather than calling it X, we call it H. So this formula that we're going to need this H equals negative B divided by 2A. If you didn't write that in your notebook on Thursday, you'll probably want to put it in there. If you did, maybe highlight it. Don't want it to go away. H is negative B over 2A. K is 4AC minus B squared all over 4A. These are two formulas that you're going to need to be able to find the vertex without a calculator, without a graphing calculator. And on Wednesday's quiz, that's going to be the hard part. Wednesday's quiz, you're not going to be allowed to use calculators. So we've got H is negative B over 2A. K is 4AC minus B squared all over 4A. Okay. So let's look then at example number 2. I'll go ahead and cut that out, put it on a new page. I said I'll cut it, and I'll put it on a new page. There it is. So if I had to graph this thing, and in tonight's exercises, there's ones just like this. It'll say graph this particular function. In the past, we knew what the vertex was, and we knew where to start right away. Well, there's really only one point that we could plot right away on this. Anybody know what it is? What point we could plot, where it's going to be? Yeah. The 3 on which axis? The X or Y axis? Y axis. Good. Our Y-intercept's 3. Okay? That's our Y-intercept. That's our Y-intercept, 0, 3. Now, do we know that that's our vertex? Do we know that that's our vertex? No. A lot of people want to jump to conclusions and say, well, that's my vertex. No, it's not. Okay? To be clear, that's not my vertex. That's not the vertex. I don't know what the vertex is, and I'm going to have to find it using these formulas. H is negative B over 2A. So if I look here, my A value, remember it's AX squared plus BX plus C. My A value, it's not real clear what it is. Or maybe it is clear to some of you. What is the A value? It's 1. The A value here is 1. The B value is pretty clear. I think it's 2, and the C is 3. So we're going to say, well, H is going to be negative 2 divided by 2 times 1, which is negative 2 over 2. What is negative 2 divided by 2? What's that simplify to be? Negative 1. Okay. So my vertex then, is going to be negative 1 something. So if I'm graphing this, maybe now would be a good time to put my axis of symmetry in here. Here's my axis of symmetry. Axis of symmetry, x equals negative 1. Here's a food for thought. Is there a different way other than using that formula for k that I could find out where the y-coordinate of my vertex is? Guess what I'm getting at is, can A help us find k? Could our A value help us find our k value at all? I'm not going to answer that. I'll just let you think about that one. So let's go back then. Let's plug in. K is going to be 4AC minus B squared all over 4A. So that's going to be 4 times 1 times 3 minus 2 squared divided by 4 times 1. 4 times 1 times 3 is 12. That's going to be 12 minus 2 squared is 4. That's all over 4. So that's going to be 8 over 4. And that's going to be how much? 2. So my vertex then is negative 1, 2. My vertex is negative 1, 2. I'm not a big fan of that axis of symmetry I got. It's kind of hard to see around it. So maybe we'll change it. There we go. Okay, so there's my axis of symmetry. My vertex is negative 1, 2. Vertex, negative 1, 2. By symmetry, I could plot this point over here, right about there. That's not a bad start to the graph, but I probably should get one more point. Now my A value is 1, so from the vertex I go over 1 and up 1. And my A value is 1, so from the vertex, what happens if I go over 2? How far up do I go? From my vertex, if I were to go over 2 units, how far up would I go? Nice. Right on. Awesome. Good. From the vertex, I'm going to go over 2 and up 1, 2, 3, 4, bam, like that, and like that. And there it is. Whoop, whoop. That's it. That's it. So being able to remember the parent function from last week is real important for this week. Being able to remember how to graph those things from last week is real important because we're going to need to be able to do that again this week. Does anybody have any questions about problem 2? Comments? How do you feel about using the formulas to find h and k? Is it pretty straightforward? A little bit of work maybe? Okay. So on tonight's homework, if you're asked to find the vertex, when I check this homework on tomorrow, I'm going to be looking, did you find h like that? Did you find k like that? That's going to be a lot of work for each problem. Good thing there's not that many problems tonight. I think ones that you're actually going to have to do that, there might be like 5 or 6. That's about it. Okay. So let's look at problem 2. Let's look at problem 2. I'll go ahead and cut it out, put it on a new page. Or actually problem 3. Problem 3. This one's just finding the vertex. This one's just finding the vertex. Actually, they want you to write it in vertex form. I kind of like this question. So your answer is going to be y equals some a value times x minus some h value squared plus some k value. So essentially, we're just going to have to fill in 3 of those blanks. And we could actually fill in one of them without doing any work. Of these 3 blanks, which one of these can we fill in without doing any work? Somebody said it. Say it loud, say it proud. Which one? The first one, the second one, or the third one? Which one? The first one? The first one. First one. Remember when we said earlier that our a value is the same thing in both forms? Remember when we said this? So we can actually fill in that first blank without doing any work. So we know our a value is going to be what? 2. Well, that was easy. Okay. So now I guess we just got to use the h equals and the k equals formula. So h is negative b over 2a. Now we know a is 2, we know b is 10, we know c is 7. So that's going to be negative 10 over 2 times 2. So that's going to be negative 10 over 4. Can I reduce that down, negative 10 over 4? They're both even. That's going to be negative 5 over 2, negative 5 halves. Okay, so I'm going to have minus 5 halves in there. That's kind of weird. It's not common for us to write minus. Maybe we should fix that. We will later. When I go to find my k value, k is 4ac minus b squared all over 4a. So that's going to be 4 times 2 times 7 minus 10 squared divided by 4 times 2. Oh, man. 4 times 2 is 8. 8 times 7 is 56. 10 squared is 100. 56 minus 100 all over 2 times 4 is 8. So that's going to be negative 44 divided by 8. Those are both even. Actually, those are both divisible by 4. That's going to be negative 11 over 2. Negative 11 over 2. So when I write up my answer, it's pretty close. It's not bad, but we could clean that up a little bit. A better way to write that final answer would be y equals 2 times the group, x plus 5 halves squared minus 11 halves. Okay. That's a better way to write that. So again, with this homework, it's not that there's anything super difficult with these exercises, but there are 2 formulas you're going to have to use. Or at least, bare minimum, 1 formula. I wouldn't be doing you any favors if I didn't show you this. Maybe you don't like to find k with that formula because that's too much to memorize. Another way that you could find k is you could go back to the original equation and plug in the h if you wanted to. So we'll have 2 times negative 5 halves squared plus 10 times negative 5 halves plus 7. Honestly, I don't know if I'd do that in this case. You know why? Because I'm working with fractions. Do you like working with fractions? No, that's why I showed you that formula. But anyway, if you do like fractions, this is going to be 2 times 10 fourths. I could cross cancel. That's going to make that minus 25. That's going to be 20. Oh, man. Oh, no, I totally messed that up. It's a Monday. That's going to be 25 fourths. So that's going to be 50 fourths or 25 halves. I don't want to mess with the fractions. I kind of like this. I kind of like this k equals formula, don't you? Okay. Cool. Well, I want to try one last example. This is it. Example 5. Last one. Find. Actually, no, we'll go ahead and graph. We'll go ahead and graph. Y equals negative 1 half x squared plus 4x plus 6. I'll try to graph this one. So I guess we got to find our vertex first. It's going to be negative 4 over 2 times negative 1 half. So I see the negative 4 up top is going to be all right. What's 2 times negative 1 half? Two times negative 1 half, isn't that going to be negative 1? So I got negative 4 over negative 1, so what's that going to give me? It's going to give me 4. Maybe I could plug that back into this one. Maybe that's not going to be that bad. Maybe that's not going to be that bad to plug back in. So 4 squared, 16. Half of 16 is negative 8. That's going to be negative 8 out of that. 4 times 4 is 16. And I mentioned this in some of my other classes. I don't know if I mentioned this or not, but if you do this right, these 2 terms are always going to be double opposites. If you end up going this route. If you think about 8 and 16, 16 is twice 8, and negative 8 and positive 16, they're opposites. One's positive, one's negative. If you found your h right and you're doing this right, those are always going to be double opposites. So let's say that's going to be plus 6. So negative 8 plus 16 is 8, and 8 plus 6, I guess, is going to be 14. So it's going to be 14. So my vertex is 4, 14. 4, 14. Is that going to fit on my graph paper, that 4, 14? Probably going to be a little bit above it, right? 11, 12, 13, 14. There's my vertex. 4, 14. Is that graph going to open up or down? It's going to open down. From the vertex, I would go over 1 unit and down how far? I go over 1 unit and how far down? How much? Over 1 and down a half. Somebody said it. So this point would be the point 3, comma 13 and a half. P's image would be 3, comma 13 and a half. When I go over 2 units, I would normally go down 4, but I go down half as much. So if I went over 2, I would go down 2, I guess. Over 2 and down 2. Over 2 and down 2. So let's see, over 2 and down 1, 2 would put me there and there. So that's going to be the point 412. Actually, the point Q and Q's image at 212. And that's it. That's it. How do we feel about being able to find the vertex? Think you'd be all right with it or no? Who uses Google Sheets? Anybody? Maybe you'll start using Google Sheets if I show you this. See if I can get logged in real quick. Always got to sign in. So what I'm going to do on Google Sheets is I'm going to create a file called Vertex Finder. And maybe you'll like this, maybe you won't. I'm going to call this Vertex Finder. I said Vertex Finder, not Vertex Finder. Vertex Finder. I probably want to zoom in. How do I zoom in on this? Anybody know where I zoom in? I can't see it. It's going to be right here. Is this going to give me my toolbar? Oh, it's going to be a long Monday, I could tell already. Oh, there we go. View, zoom. There we go. Make it a little bit bigger. That's better. Okay. So I'm going to call this Vertex Finder. I'm going to put in my A value here. I'm going to put in my B value here. I'm going to put in my C value here. I'm going to have it return my H and my K. Is anybody picking up what I'm putting down here? You see what I got going on here? So let's look at that last one. The last one, my A value is -0.5. -0.5. -0.5. On that last one, my B value is 4. My B value is 4. And my C value on that last one was 6. My C value on that last one was 6. Okay? Everybody see what I got going on here? So I'm going to go to column A. I just want to center these. It's just a thing I like to do. So I'll center each one of these. It's probably a faster way to do that, but okay. All right. And I could probably make this a little bit bigger font. Maybe I'll make it 18-point font. Maybe I'll center that across these 3 cells if it lets me. These 4 cells, 5 cells. I'll merge and center that. There we go. Okay. So my H value is equal to negative, my B value is in cell B3. So I'm going to put a B3, and I'm going to divide that. I'm going to divide that by the group of 2 times, I can't see my asterisks. Anybody see the asterisks on there? I can't see it. Times, there it is, times, it's over 2A. My A is in cell A3. My A is in cell A3. So I'll go ahead and close the parenthesis. And is that the right H value? 4? Is that what we had? Oh, this is cool. This is pretty, this could be handy. K value is in, oh man, is in the numerator 4. I need my asterisks. 4 times A, which is going to be A3, times C, which is going to be C3, minus B, which is going to be B3, and that gets squared. That's all my numerator. That's all divided by my denominator, which is 4 times A3 times C3 times C3. And if all is right, this should end up equaling, let's see, 4AC minus B squared all over 4AC, right? All over 4A, all over 4A. 4AC minus B squared all over 4A. All over 4A. I don't need the C there. Enter. Oh, that's it. You see this? I could go back and try this on some of my other ones. Let's go back to that 1. That first one we had 2, 8, and negative 2. 2, 8, and negative 2. 2, 2, 8. So this one was 2. 2, 8, and negative 2. And our vertex on that first one was 2, negative 10, or negative 2, negative 10, wasn't it? Do you see what I just did here? Would anybody like to have a copy of this this file for their using? I could what? I could send it to you? So what am I going to do? I'm going to rename it. I'm going to call it Vertex Finder. Vertex Finder. And what if I put it in Classroom? Would that be all right? Would you be able to get to it off of Classroom? Would you be able to use it to do one like? Would you be able to use it to do one like number like problem 2 here? So we got 1, 2, and 3. So we got a 1 and a 2 and a 3, and our vertex on that one was negative 1, 2. That's pretty cool. That's pretty cool. I'll put that on Classroom. Will that help you? Any questions? Comments? Any shout outs? Shout out to the future Mr. Minnick. He's trying to grade your quizzes so he can get them back to you. Have a terrific day. See you. Good.